All right, we're at time. So, yeah. So I created this presentation actually a while back, and it's been updated multiple times. But um, I hope you like it. Let's see at the end of the session. But I'm here about to challenge any assumption you have. That's what I'm trying to do. I'll provoke you quite a bit. You might disagree with me. I hope you do. I'll challenge the things you know about cloud, about systems, services, whatever. Question every best practice because that's my job. Um, the last 12 years, I've been at the forefront of technology, working at the role I have at Microsoft. My initial role was technical evangelist, which was fun as hell, if you're allowed to say that. Try to push the boundaries, and my job just morphed into different roles of the same thing. And this summer, they decided to call me an architect, whatever that means, because I'm not really doing architectural work. I work with strategic customers at Microsoft, enabling them I don't know, app migration to the cloud, AI enablement, what's called digital transformation, all these kind of weird things. And I work with large players such as Nokia, Volkswagen, Shell, Novo Nordisk, what else is there? WHO. There's been so many different customers I've been working with over the last 12 years. I work internationally and do a lot of these things. I gotta highlight that this talk is not a Microsoft talk. I will be referencing a lot of Microsoft stuff because that's what I know best. And I'll even highlight some of the things that Microsoft do. But this talk is super opinionated. It's my opinion. It's not Microsoft's opinion, and it might not be yours either. But it is super opinionated, and I'm basically going through some of the things I do when I talk to customers, the strategic business owners or whatever it is, or engineers, because I talk to every level in the stack when we do projects with these customers. A couple of other my colleagues presenting here today also, are actually from my team, Tess, and a session in number 2 right now, for instance, and Mark later. You're welcome to ask questions. Do interrupt, raise your hand, shout, throw. Please don't throw things at me. But there'll also be plenty of time to ask questions afterwards, and I would love to discuss some of these things if you are experiencing some of the challenges or anything like that. But let's get started, and we need to get some basic stuff settled first. So bear with me when we go through that. First, the agenda. So why are we doing cloud at all? What the hell is cloud? We all know that, but I'll just briefly settle on some of the things because they are super important to why we're doing cloud. Talk about some of the cloud challenges, the primary 3 ones. One of the mitigating strategies is cloud agnostic or multi-cloud strategies. We talk about innovations and the trends going forward. And that's the section I'm going to focus most on Microsoft because I know what's going on. And then we're going to talk about a little bit, not much, because you probably know a lot about it already, but cloud, composable cloud architectures. Yeah. So why are we using cloud? Cloud is just a data center. Like, there's nothing specific about it. But yet, there are some changes. There are some minute differences compared to, let's say, a regular hosting center or whatever it is. And you probably know all this, but I'm going to run through it anyway. But the major cause of why we started with cloud and everything was when AWS invented it first and then Microsoft copied it. It's about economy of scale. Like when you buy 100,000 units of whatever it is, or 1,000,000 units of CPUs from AMD or whatever servers, the cost of per unit just goes down. This is about the bulk purchasing power. One of the things that people don't really recognize is the operational efficiency also. Sure, we place a data center near the Hoover Dam so we get electricity at super low cost. Others can do that too. But can you hire a group of engineers, spend 3 years trying to figure out whether or not we can save 1% in heating reduction, the heating bill, cooling, not heating, and have that with an ROI that's positive. We can, because we've got millions of servers, and we do that every day. If you're ever invited to an EBC or to Microsoft and stuff like that, or any of the other cloud providers, go there and see some of the innovations going on there. I'm going to share a few of them, but they're super interesting. Everything is super optimized, specialized. Like there's literally no electrician. It's not true, but in these data centers, everything is optimized, automized. So it's specialized specifically for that thing it's supposed to do. Like we don't, for our internal services, we don't use general purpose CPUs for anything, for instance, because we could optimize. We might cut 2, 3, 4, if we're lucky, 10% off of the cost or the heating or whatever cooling bill. That leads to all the innovations that we're seeing. For a customer, it's also about cost. Doesn't necessarily mean that the cloud bill is going to be less than your hosting bill at home. It might, hopefully it will be, but it's not necessarily true. And it depends on what kind of data you incorporate in that one. So, for instance, the OPEX versus CAPEX cost, right? Upfront servers buying, need to spend $1 million, whatever currency, getting the servers, the fast procurement, like you go into the portal, whatever it is, or run your script, and 3 minutes later you have that system up and running, compared to 3 months at some companies, even longer. The scalability and flexibility, we're all aware of that. Like, if there's resources available, you can scale more or less endlessly, but sometimes there's not resources available, even at these major cloud providers. And there's some cost predictability when we run these services. I added the word some cost predictability because when you start up your service and running it in any cloud provider, you actually never have any clue. I'm continuously asked, how much will it cost to run the system? And I guess every time, because I have no clue. Once it's run in a couple of months in the cloud, you sort of know it'll cost you $2,000 a month, or whatever it is, and if there's a few extra users, it's $2,200 a month, whatever it is. The speed and agility is something we don't talk much about, but it's super interesting, like the fast provisioning, like I mentioned before. The rapid experimentation, like you look at this new service, does it make sense to change from, I don't know, Microsoft SQL to Microsoft Cosmos or whatever? That's a big shift. There are companies, even in Denmark, that I work with, that look at chipsets on the architecture and saying, okay, if I change from this chipset to this chipset, or from this processor to this processor, can I get a gain of 5%? That's worth doing the shift. So rapid experimentation. The scalability or elastic scalability, the global reach. So right now, Microsoft is opening a new region per month. We're at 70 something, 80, close to 80. We got more than 300 data centers. There's 3 in Denmark. They're not open yet. 2 of them are actually done, but the last one is not. That's why the region hasn't opened. And then the generally the reduced time to value. But if you look at engineers, the appeal is so different. It all boils down to one thing, and I'll get that to the end. So rapid delivery of environments for test development or scaling production. This self-serve infrastructure. That's the thing that sort of made cloud really, really nice. You have improved reliability and reduce environmental drift with infrastructure as code. You define how the environment is supposed to look like, and you can replicate as many times as possible. And if somebody with the right access goes in and change something, you can detect it immediately. A single flag on a web app can change the behavior. So this infrastructure as code sort of gives you the ability to version control your infrastructure. You have auditability, super interesting. And it also integrates super well with the DevOps processes, continuous integration you already have, and continuous deployment. So you have seamless integration there. And another thing that you don't really think that much about, especially as an engineer, is about the security and governance, like the data privacy, the encryption, identity access management. It's that easy. And And especially the regulatory compliance, if you're in a specific industry, like where you need HIPAA or GDPR applies to everybody, but there's ISO certification. All these certifications just handled for you, which is super nice. But it all boils down to, as an engineer, the appeal is, I got an API. Like, I don't need to talk to anyone. I can just use this API to interact and do whatever I want. Like, it's the same with generative AI today. It's an API. You don't need to learn all the intricacies of machine learning or deep neural networks or whatever. You, as a general purpose engineer, can actually utilize and get huge benefit out of generative AI just because of the API. And it's the same thing here. You don't need to learn how to, I don't know, patch a server, all that stuff. It's handled for you. So, the cloud challenges. The most cited one is always vendor login. Like, it's difficult to switch from one cloud provider to another because they have specific APIs and services. You might utilize Cosmos DB in Azure and want to move to AWS, and then, you can't really do that. You have to rewrite your application. When you provision your services infrastructure as code, you can sort of utilize Bicep or ARM, but doesn't really apply well over to AWS. It's new skill set. Like, you need to know what kind of benefits to have out of that service provider. Like, there's benefits. For instance, if I use, let's pick Cosmos Database again. If I use Cosmos Database and then use caching, then every request is free. I bet none of you knew that. Like, so if I have, when I do a request to Cosmos DB and I ask whether or not it's in the cache, and if it is in the cache, that value has not changed since, then you're not hitting your ROU, which is called in Azure Cosmos DB. Or when you provision a disk, which I hope none of you do, but if you provision a disk, you don't pay for the, you only pay for the data you use, not the allocation. So you always provision a disk that's a terabyte size or whatever it's supposed to be. There's things that you need to know, and some services are provisioned or build per minute, others build per hour. For instance, if you take SQL Server and test it, spin it up, shut it down, spin it up, spin it down. At Azure, it's built per hour, not per minute, like every other service is. Weird stuff, but you need to know these things, otherwise you can't really utilize that. Then there's the high mitigation cost, or you end up having a reforming project. Skills and tooling, so we already got into that a little bit. So it's basically because it's all proprietary services. Then the costs, like cloud builds are complex with thousands of lines, item lines spanning compute, storage, networking, etc. Most companies don't have most teams inside companies don't really have insight into how much the system costs that they're running. They're never really looking at it. They're not aware of it. It might be handled by a FinOps department somewhere else. And often you over-provision. Like, I remember in the old days before cloud, or actually still in cloud, when I was asked, okay, you built this system, what kind of hardware are you supposed to run it on? I had no clue. So I always said at least 32 gigs and 16 cores, even though it's a simple website. And I end up with utilization of 2-3%. The same happens in cloud. The point here is that a lot of companies does not reevaluate after 3 months and turn down these utilization costs. The lack of engineers often don't see or feel the cost of that infrastructure. And then there's the inefficient usage patterns. Like, you got to be aware of what you're doing. You can't just take your existing on-premise skill moving to the cloud or moving from one cloud to another, because there are intricacies that's difficult to handle, like frequent small database requests. That's super expensive. You're not aware of it because if you have a super chatty application and it hits a lot of AI, the backend, the cloud will just process them as quickly as they can, but you'll be charged per request. So your app will probably be more expensive running in the cloud than on-premise. There's excessive locking retention and overused verbose locking. I see that everywhere. Like, It's not uncommon that half of your cloud cost is logging, which is generally not a problem, but you need to have that large a cloud cost for that. And then architecture-wise, how are you designing your system? Polling versus event-based. Polling is super expensive. Again, that's I/O you request. You think about the number of minutes you run the CPU, but no, you need to think about especially about the I/O you're doing all the time. And you have no clue whether or not that request requires 1 IOPS or 1,000. But you need to look at all that. Data gravity is a major thing, especially at large enterprises, because once you got all your data in AWS, it has a tendency to automatically just be the standard. I build a new system, where it's supposed to run? AWS, on whatever service it is. If you start moving it out, you sort of run into issues with egress cost, meaning data transfer cost between regions, data centers, whatever it is. You're gonna get a performance and latency hit, and you're building this system, you don't want to have a slow system. Hence, you'll default to AWS or Google or Microsoft for that matter. This just amplifies the lock-in and sort of is a challenge for multi-cloud and or hybrid strategy or agnostic solutions. So, especially large companies, they migrate this risk or these cloud challenges with multi-cloud strategies or cloud agnostic strategies or hybrid strategies. They have a lot of names, and that makes sense for large companies. So the appeal for multi-cloud is the major appeal that people talk about is this negotiation of leverage, the risk mitigation of what if Microsoft goes bust tomorrow? They won't. What if Microsoft raise their prices with 100% tomorrow? Then your business will go out of. These leverage in contract negotiation or reduces the exposure to outages, price increase, or policy shifts. If you're a large user anyway, you have that leverage in. You have that leverage. You don't need to have a multi-cloud strategy. You don't have to build your systems so they're multi-cloud. You'll have them anyway. If you're large, if Maersk comes to Microsoft in Denmark and saying, okay, we don't like you anymore, we want to move to Google, you have the leverage. We have no clue whether or not your system is transferable anyway, so it's not a problem. Then there's the optimization of cost and performance. Because different cloud providers have different services. They have strengths in each region, workload or services. And you'll be able to utilize all of these different services. You might go to Microsoft for OpenAI and Google, AWS for Fargate or whatever it is we want to use. The point here is that, yes, you can micro-optimize, but all of these hyperscalers compete fiercely on cost. So if AWS lowers the cost of storage by 10% tomorrow, it'll be weeks before everybody else does it, because we cannot lose that revenue. And then there's the leverage innovation. Like no single cloud provider is leads in every category. Like if you want today, for instance, if you want to have the best of breed of services, if you want to do enterprise integration, it's Azure. If you want to do serverless for high maturity, it's AWS. And if you want to do data and AI, it's probably GCP. Or is it Azure today with OpenAI? Everything changes, right? ChatGPT came out and all of ChatGPT services run on Azure. Microsoft owns half of OpenAI. So we sort of leapfrogged everybody and become the most a desirable cloud provider for data and AI. And we weren't before at all. But if you look at some of the services the others are building today, they're just as good, many of them. Some might even be better to your workload. But that doesn't, so you can micro-optimize, move your services to one provider, and then 6 months later move to another. Most companies don't do that because your system, it's costly to sort of move things around. And then the major thing is this vendor lock-in, which we already talked a little about and explore it a little bit more. Companies rarely re-platform a stable production workload unless there's a major business shift. I don't know if you're Musk and Microsoft suddenly goes into shipping and becomes a competitor. Like, yeah, sure, then we'll probably move our workloads to GCP or something like that, or Musk will do that because they don't want to hand over data, traffic, and all that stuff to a competitor. Cloud migrations are so expensive, and switching providers introduce downtime, regression, all these challenges that business just wants stability. Like, so when you build a system, it runs there until most of the system runs there on that technology stack with that SQL server, whatever it is, until it dies, and then you build a new one. That's not an uncommon pattern. And then if you look at a little bit at vendor lock-in in overall, there's some you're doing all this stuff to, let me rephrase that a little bit. But the trade-offs of going in for a cloud agnostic, multi-cloud solution is clear, because if you leverage cloud native services, when I say cloud native, it's not CNCF, it's specific services for that cloud provider, you sort of get speed, agility. Is that important to you? And if you design everything to be portable, it just adds complexity. And you'll, in most cases, never shift from one cloud provider to another. And if you look at, then there's services like, I like Kubernetes, but also dislike Kubernetes, for instance. That's one of these abstraction you add onto, I'll run my services on Kubernetes. But that's just another level of lock-in. And if you start up with AKS and Azure, you'll soon add some services that ties you even more into that ecosystem. The same with the SQL Server. In 2000, when I started developing software professionally, everybody was doing data access agnostic solutions with Hibernate or whatever they were called. I've never, ever heard about a system that migrated from one database to another. It's the same with cloud. It could be, I don't know, you adopt S3 compatible storage, still just an API dependency you add. All the choices you do is about dependencies. Yes, so when should, of course, you will need once in a while to build agnostic system and stuff like that, and you will need to build multi-cloud strategies and solutions for some customers. But you need to be very crisp in when you're doing and why you're doing it. Like, I basically categorize it into two things. The one and only business critical system you have, because pretty much every company only has one business critical system, and everything else. And everything else I don't want to talk about because it doesn't make sense. Like, let's take Maersk again as an example. What is their most critical business system? I can tell you it's not their HR system, it's not their invoicing system, it's not their website, it's not their, I don't know, what else is there? Trading system. They all go down to the bucket saying all others, which we ignore. It's one thing. It's the logistics system. Where is this container? Where is it? Who owns it? Who is supposed to build? Everything can be down for a month and Maersk will still survive. But that single, some company has more than, it might be a complex of systems, is the important part. Everything else is irrelevant. And even though when you talk with business managers and you ask the HR manager, all right, what's the expected uptime for the HR system, the payment role or whatever, at least 5 nines. But once they get the bill for those 5 nines, they say no thanks. Right? And that's the thing that you need to show them. That's not really relevant. So once you just figured out why this system is super critical, it's supposed to be portable, it's supposed to be multi-cloud, that's where you can start discussing costs, because this portability has a cost. And there's some stats here, I'm going to have to read them up a little bit, because I don't remember all of them, but there's engineering cost, people and time. Like you're designing the API, it's agnostic to the database, it's agnostic to whatever services you're using. You need to have skills duplication if you're both using BigQuery and Fabric, BigQuery in Google and Fabric at Microsoft. There's two different skills you need to have. The maintenance, wherever you build a new feature, you have to test it whether or not it works both at BigQuery and at Fabric, at Azure. Just the engineering cost, people cost, is 1.5 to 2x the cost when you build the solution. That's a lot of money. And then there's the operational cost. Like once you have the system running, like you need to take care of, okay, we have two different monitoring systems. We have Kubernetes, it might be Kubernetes running both in Google and at Microsoft. They are maintained two different ways. There might be two different identity management systems you need to consolidate, and you're using two different, I don't know, service mesh. You probably shouldn't, but you could. One prefers one and the other prefers the other one. And that adds up to 1.2 to 1.4x just operational cost of a system that's portable. And then there's one thing that people don't think much about is this slower time to market. Like if you build in cloud native services, and again, not CNCF, I'm not talking about CNCF at all, more or less in this talk, such as, and these cloud native services is AWS Lambda or Azure Cosmos DB or web apps or container services or whatever they're called, you're re-implementing functionality. If you don't use some of these, you're re-implementing functionalities, sort of like, how do you, building your own Kafka or Postgres or Kubernetes cluster. This means delayed feature launches. It's an opportunity cost for the company you work for, instead of getting that feature out as quickly as possible. It adds approximately 50% on development time to build these agnostic solutions, which is a lot. So the overall cost of going cloud, multi-cloud, cloud agnostic, is roughly 2 to 3 times what it would cost to go cloud native. So I keep asking when I'm in this situation with these stakeholders, right? First of all, why? And I keep asking why. And if I talk to engineering, they have, because Kubernetes is cool, multi-cloud is interesting, there's a lot more features I need to use. I need to use Grafana, and I want to use all these frameworks. So do I. It's fun. But it has to be a business decision. And once we drill down into why and ask up in the management chain also, we often find that there's no business decision made, especially not one that can incur a cost of 2 to 3x of the development time. Because who should be making that decision? That's also one of the discussions I always have. Like, who is it that makes this decision? Is it me as an engineer? Is it me as an architect? Is it me as a business owner? Is this the CFO or CTO or whatever it is? It's probably a combination of all of it. So, multi-cloud is not without challenges. I address some of them, like the increased complexity of managing multiple platform, API, services, SLAs, the overhead operational, like duplicate monitoring, logging, CI/CD platforms and all that stuff. Data gravity, we mentioned that a little bit. When you move data from one data center to another, it costs you money. And latency, tooling, backup, DevOps, tool chains, observability, all these things. Cost management. Now suddenly your FinOps department needs to go out and purchase a tool that sort of can aggregate and compare somewhat these apple and oranges, because you can't really compare one service in Azure to one service in GCP. It's not really doable. There's the skills gap. Like you need to learn all the features. Like I mentioned one of the things with Cosmos DB that probably none of you are aware of. Most of my colleagues at Microsoft doesn't even know that either. But it's a benefit to know that these kind of things. And I'm proficient in doing a lot of things in Azure. If I have to switch over and do something on GCP, it'll take me a lot longer. That's the cost we talked about. There is the security and identity fragmentation, which the security folks are super concerned about. Like suddenly you have an identity management. Either you adopt, let's say, Azure Entra, the old Azure Active Directory, and use that on Google, or you have two different systems. I've rarely seen that situation where you suddenly have two different systems, because then the system needs to have two different identities and becomes difficult to manage. So you end up with a solution saying, okay, Microsoft Entra is the premier used by a lot of companies, hence I use that across my GCP cloud also. Then we have a single point of failure, and it depends in there anyway. So, and the alternative is an increased attack surface, and compliance and governance also becomes a thing, especially in enterprises, where you have to apply policies. Like, I don't know, all services are supposed to be within a VNet, and no services are allowed to use credentials. They should all have a managed identity, when we're talking Azure, for instance. Audit trails become super complex. So I'm not going to go through this, but the deck is yours. There's a long list of things you need to go through. So for a readiness, if you want to go multi-cloud, and multi-cloud applies to hybrid and cloud agnostic systems also, business strategy, skills, organization, architecture. But there are three things I want to highlight. Like the business justification is the most important one. And then the second one, getting the business justification just right. They should be aware of what they are setting out to do, and you should be aware of it too. It's fun to build these systems. I know, I've done it multiple times. The next level is where most companies fail, is strong engineering and automation maturity. Automate everything. And I literally mean everything. So if you run a solution on Azure AKS again, and once in a while Microsoft upgrades these systems, how are you handling that? And once in a while we deprecate an old version of Kubernetes. How are you handling that? Because you need to follow along when you're in these cloud providers. It makes sense. How are you handling that? If you're doing anything manually, I'm not saying you're not mature enough. So it even applies if you're using Azure Functions, which is the serverless, one of the serverless platforms in Azure. They keep upgrading and deprecating all the versions every, I don't know, not month, but close to. If you haven't automated that upgrade and testing and verification of the system, you're not done yet. You're not done automating. You're not mature enough to go multi-cloud. And I'm pretty sure none of you have done that, because I have never, ever visited one of those companies that I talked about earlier that has done that. And then there's the last thing I want to highlight is the unified observability platform. So once you go this multi-cloud, becomes a little bit muddy, but you need to have one way, and you need to figure out how to unify these two systems. So Azure might give one signal, and AWS might give another signal. What's the difference between these two when they say, I don't know, high utilization? Azure might already give you that signal at 80%. GCP might give it you at 95%. I have no clue. This is just random things I'm coming up with. But you need to handle those things differently. So you have a lot more to do there. But just highlighting the engineering and automation maturity is where most of these projects failed. So let's look a little bit about the cloud innovations. And I'm going to be super Microsoft specific here, because that's what I know about. And I'm not sure what's happening in the new things they're building at GCP and Oracle Cloud and what they're called. But let's start here first a little bit, because cloud, again, going back to this is a super old diagram. I've used it the 12 years I've worked at Microsoft. Actually the same diagram. I renamed the title, otherwise this is the same stuff. It's old. Like, what is on-premise? Who's responsible for what? The shared responsibility model. The infrastructure as code, where the cloud provider takes care of storage, compute, and networking, and platform as a service, where they take care of the operating system and runtime and stuff like that. That's the first level of maturity. Like, they're taking care of more and more stuff, and I'm super advocate of going as far right as you can for pretty much all systems. And you see, and you're not really supposed to look at this slide, but you see this is also an old slide, but there's so many services in Azure specifically. There's 80 plus right now, and it's not even all of them on this slide, doesn't really matter. But you see innovations happening, and this is a super interesting one that was announced, and I think it was in November. It's actually a video if it can play. Yeah. Doesn't play, but it's buffering now apparently. No, but this is hollow fiber that Microsoft is building is to get a competitive advantage over others. So Microsoft have perhaps the largest or one of the largest fiber optic networks in the world. We have these 300 data centers, all connected by our own fiber. And how can we optimize the fiber? Like, they're building these hollow fiber because light travel faster in vacuum than it does in glass. So we can get a lot more data through the same fiber, with this hollow fiber, than we could with regular fiber. So this is something we built, designed. And if you look at some of the other hardware things we're doing, this is, what's that called? A storage controller. So in all the servers, there's this storage controller built into it. And on the left side, you see two 100 gigabits network interface cards. In the middle, you see an FPGA that sort of handles a lot of data-specific processing. All of this is actually called a DPU, data processing unit. And on the right side, you see a little chip here that's running an ARM version of an ARM cores running Azure Linux. And why have Microsoft designed and built this? First of all, it's a competitive advantage because we offload all IOPS processing from the GPU down to this board, which means you'll be able to get a little bit more out of the services you're running. And because of the FPGA and the ARM core processor, it's cheaper for us to run. There's other innovations. So you have the DPU on the right, you have the hardware secure model that we built. There's also the other processor. We're going into the processor business. Microsoft is so big, so they're going into the processor business. So it's again an ARM Cobalt processor. When you start a service in Azure, you can sort of use these. You can pick that one if you want to. Today, most people just pick, I want an A1 or B1 or C1, but you can actually go in and pick ARM processors, which ARM processors in general, if your code can run on ARM, is up to 80% more efficient than running on an Intel or AMD processor. There are weird things such as, because I like sustainability, that's an area I delve a lot into. There are weird things like construction of the data centers that's changed. Not the Danish one, unfortunately. I would love to have seen that because this is fairly new. So instead of using concrete for everything, steel and concrete, they use cross-laminated timber to reduce the carbon footprint of the levels up to 65%. And then the concrete foundation is infused, what's it called? It's biogenic limestone, which also limits the carbon emission by roughly 50%. These are some of the innovations that we can take on that the local hosting company probably not. I just like this stuff, that's why I brought it along. So, cloud trends. I just showed you some of the things and the innovations are happening. So, the cloud trends, everything is AI. You knew about that. Like, everything we touch is AI. It's going to be everywhere, omnipresent. They're trying to evolve into AI infrastructure and platform powerhouses, all these hypervisors. And there's massive investments in the GPU, TPU, the other stuff I showed you before. Microsoft alone in 2024 invested $100 billion into AI, which is, can't even fathom that amount of money. And the others are doing the same thing. And you see more and more advanced services. You and I have probably been playing with OpenAI, Gemini, or anything like that, and some specialized services like Copilot, GitHub Copilot. But you're not aware of some, I don't know, Code Whisperer and GitHub Autofix, which I really love. But you're not aware of innovations like nuanced tracking. So if you go to the doctor, for instance, in the US, and it's American only, right now, because of GDPR, nuanced tracking is actually an app, a tool set that runs on your phone. So when you're sitting with your doctor, you have the dialogue between the doctor and the patient. It records everything, creates a summary. It knows about all the medical jargon and all that stuff. It creates the prescription, creates the next appointment, all that stuff. It sends a text message with a summary in normal language to the patient also. This is super interesting, and we see more and more of these advanced scenarios coming up. You're going to see the cloud providers focusing more and more on developer experience. And this has been a competitive advantage that people want to look at now. And it's not only developers. Like, if you look at the rise of low-code, no-code platforms, if you think about the implication that will have with AI. So I think, probably not my mom, but my sister, she works in a daycare. She would be able to go into some of these low-code platforms and build an app or build a system that sort of tracks, I don't know, number of kids in the daycare every day and what kind of meal. She'll be able to do that with these kind of tools. It's changing a lot. So it generally lowers the barrier for cloud adoption. It makes it a lot easier. Today you can use GitHub Copilot or whatever tool you're using, Claude, to sort of generate this infrastructure as code that you're using. So you're sort of shifting your mindset a little bit to, instead of manage everything, you sort of curate and you orchestrate instead. You're going to see verticalization and industry cloud and sovereignty is difficult words. Again, if you look at Microsoft, which is the one I know best, we now have cloud for healthcare, for automotive, for defense, for all these, and they're building specific services. I know a little bit about the healthcare leg, so I'm going to talk a little bit about that one. But for electronic patient journals, there's a standard called FHIR, for instance, that's being used. EHR. There's services in Azure today that you can spin up that's relevant for a hospital. You see these sovereignty things like GovCloud from Google, or the EU Parliament, whatever it's called, specific data center in Germany that Microsoft has built. So it's built specifically for those and with lots of constraints. So whatever Trump figures out, it probably can't do it anyway. So there's a lot of innovation happening in all these different areas. And then, for instance, some of the services that you probably haven't really realized are there, but they're super interesting. This, I think, was built. Microsoft announced the Azure SRE agent, site reliability engineer. I'm working with a couple of independent software vendors with this one, and it's super interesting. It's a tool that's grown internally. Internally, it's called Azure Brain. Really like that name. But it's about using AI to manage operations of Azure. And it's been turned into a product so you can utilize it. And it's super interesting to follow the confidence of this tool rising inside Microsoft. So initially it was built around, so we use GitHub a lot to manage Azure and stuff like that. But initially it was sort of built around giving indication of we're looking at logs and we think this is happening. And initially it was just asking you, does it make sense for us to reboot this server, whatever it is, to sort of handle this incident that's arising. And we got thousands of incidents. But they're getting at that level now where that is automated. Not all situations, but if we detect this pattern, this is the mitigation the AI will do without human in the loop. So this is super interesting, and this is coming out as a actually it's already there as a public preview. Again, it sort of ties you even more into Azure, but you're gonna get that benefit. Another thing that you probably haven't talked much about or seen much about is this Microsoft Discovery, which I think is perhaps even bigger than any of the things we've seen otherwise. So Microsoft Discovery is this graph-based science solution for researchers. Like, it's not for engineers, it's not for data scientists. It's about material design, it's about drug discovery, it's about chemistry, physics, and other things. And again, diving deep into, for instance, life sciences. If you have using graph-based knowledge engines such as RAGgraph and stuff like that, you can retrieve interesting facts about materials. Like if it's a molecule and you want to design a new medicine, for instance, you have ideas or you have data about the characteristic of that molecule, and if you combine them, you sort of get an idea of what you can do with these. This is what drug discovery people do. They're taking all these thousands and different materials and trying to figure out, if I pick this one and I combine them into something, I might create a new weight loss drug or whatever it is. But you're not really sure. But there's a lot of people in data science looking at this. Now, my discovery is going to do this with AI, and we're working with a number of pharma companies doing that. So you have all this data. You use AI to predict what's the impact is going to be merging these two molecules. Then you use AI again to figure out what's the optimal plan to test this. Like what kind of experiments I'm supposed to do. And what is the cheapest experiment that I need to do? And I'll do that first. And if that fails, try something else. And if it doesn't, try this experiment and this experiment. It actually goes so far, so it automates lab robots. This is part of this too. So you take this molecule, you isolate this molecule, you combine them with robots, you do all the testing. And you eventually you can test thousands and thousands of combinations per year, months, or whatever it is, depending on your resources. But this is super interesting, because what we're taking here is the DevOps approach into material design. We're taking out, then we're still going to need data scientists, we're still going to need researchers and stuff like that they can verify once it gets out. But once you'll be able to do material discovery or drug discovery at that level, at that speed, 24/7, then you'll be able to do all these things a lot faster. And Microsoft is moving into this area, which is something I didn't see coming 2 years ago. It's going to be super interesting, and Microsoft is probably not the only one. I don't know if GCP or any of the others are doing this, but it's super interesting, especially if they can cure sickness, illness beforehand. Yeah. Yes. The question was whether or not there was digital twins and all that stuff. Yes. So we're actually working with a partner to control the lab automation, but it's all AI. I'm part of one of the projects, especially in life science, and it's super interesting because it's basically AI producing a summary saying, take this material, combine it, use AI to create a plan, use AI to tell the robot what to do, and the outcome is more or less binary. So there's a lot of AI calls. In this project, there isn't much code. It's just things that sort of talk to each other in sort of a natural language. And that's actually a fairly good segue into some of what I wanted to talk to here at the end. It's about, I see a shift coming into what these cloud providers can do, and serverless 2.0 is probably not the right name for it, but I do see a lot of things going in that direction. You're going to see, again, let's pick serverless function, Azure functions, or Lambda in AWS. They're going to be super more intelligent, meaning why not make the decision of, you want to run your code somewhere, but you don't really care if it's in Sweden, Denmark, Norway, within EU, for instance. I just want it cheapest and fastest. Why don't let Microsoft handle that? Or AWS handle that, and they'll figure out where to run it. If it occurs a cost for storage, Microsoft have to handle that too, because you don't want to pay extra. That's going to happen. If you have a huge workload, let's HPC, high performance computing. I need 100,000 cores doing something. Today you have to say, I want to spin up 100,000 cores up in Sweden Central, and then run my compute workload for 3 weeks and then shut it down. Why don't use Azure Batch, as it's called, and tell that service, I want to run 100,000 cores. My data is there, run it. And by the way, I like EU, not the US. So that's a level of serverless you're going to see, and you're going to see more of the services that we have having a serverless financial model. So you don't pay per minute, you pay per execution second or whatever it is. So serverless is a modern composable architecture that extends beyond function as a service to include long-lived processes, whatever that is, and event-driven containers, stateful workloads, and rich development experience would still eliminate server management and scaling concerns. So I just want to have my data somewhere. For instance, Microsoft claims, I've not tested it, but we've used in Fabric. You don't have to worry about I/O. It's unlimited. Of course, it's not unlimited because there's a lot of disk underneath, but there's probably not a company that can saturate Fabric. Because there's got, even though if you pick a region, a smaller region, Denmark East when it opens, still going to have millions and millions and millions of IOPS. So, yeah, good.
Why could I not come with a requirement that you want in the cloud? If you build something,
So the question is, why not, as a customer, come with a requirement saying, I want to be able to migrate my workload from one cloud provider to another without anything, right? That's sort of the question.
Yeah. In theory, I could move it, but of course, you've got to provide the best service.
Yes.
Don't do it, but it's like an optional thing.
Yes. So being able to move, so the question again is about why don't customers demand that you'll be able to move your workload from one cloud provider to another? I think customers are trying to demand that. There's been multiple attempts to do things like that, like CNAP, Cloud Native Application Bundles. What's that? A unified. There's a couple of things, but never really gotten around to it. Microsoft had an initiative when they still was trying to fight Kubernetes and saying Service Fabric is way better, which it is. No, it's not. So they had an initiative there where you're supposed to define your application in this abstract language, and then there could be implementations for different cloud providers, and never really succeeded. And a good example is Terraform. Many of you are probably using Terraform. I would not recommend it. It's not great. The innovation is not happening there, and you end up in that situation anyway where, again, my personal opinion, you end up in that situation that it's not optimal implemented for all platforms, and there's some features you can't use, and you have to go down and implement that Terraform feature yourself. Yeah. So I personally, in most cases, go directly and use cloud native and not CNCF again, but there's services. If I'm in Azure, I'll probably use Bicep because it's just so much easier, so much faster. And I don't have the potential problem of lack of compatibility. And there's always, again, in Terraform, somebody made a decision somewhere whether or not this translates into X or Y in Azure and X or Y in AWS, and it's not visible for you. And you don't realize it until 6 months later when the system is not running optimal or something like that. So this cloud composable architecture, composable architecture is a cloud-native design, and when I say cloud-native, again, not CNCF, cloud-specific services, design strategy that enables organization to assemble and reassemble services into tailored solution using standardized modular building blocks. And going back to that discovery we talked about before, and then look at this architecture. This is just random one I picked up. This is an AI application. I'm a software developer, that's my background. And this application is a running application. It's almost no code. It's infrastructure as code, if there's any. That sort of, it has a web front end. Yeah, sure, you need to make something pretty there with HTML. But it connects to an Azure service bus, which is connected to an Azure function, which there's a small piece of code there that figures out to send it to document intelligence and extracts information out of that document. Then it sends it to, stores it in Cosmos DB, and then it indexes that with a vector store. And the front end also has a search front end. So this is a large AI solution with, I would say, 1,000 lines of code. I'm not really sure how many lines of code there is, but there isn't much. It's just small snippets everywhere. You probably can generate a lot of it with AI, and then you have a running RAG application. Or you can, of course, go the other way with low-code platforms like Power Platform or Lovable. I don't know if you've seen that one. Lovable, a Swedish company that's the fastest growing company in the world. They started in 2024. They're a year and a half old now, and they're worth $10 billion. So, my key points, the takeaways. I've been rambling a lot. I've been trying to challenge you a little bit, and you're probably sitting there and saying, he just wants everything to run on Azure. I don't give a shite. I work with a lot of customers. They run stuff on AWS. We help them there. That's my job. I'm not here to try to sell anything. I know Azure best. If I was building a startup tomorrow, I know exactly what I would do. I would not use Kubernetes. I would use the cloud-native application blocks. Run it on Azure Container Apps, for instance, using a Cosmos DB or whatever it is, depending on my needs, of course. Because I know all the small intricacies. I know where I can get the benefit, where I can get the performance. I know all these things. And I can probably apply most of that to going to a GCP also. So embrace that innovation that's coming. Like, I'm not talking about AI specifically, but I'm talking about these services that are showing up. Azure SRE agent. It's going to be super interesting. Otherwise, you can't stay competitive. Like, if you spend 2 to 3 times the amount to develop the solution and it's half a year later deployed, you're probably too late in an ever-changing market that's going to go more and more rapid. So embrace that innovation. Don't focus on vendor lock-in. This is probably the most controversial thing I'm going to say, but I'm not worried. Like, when you build a system today, the amount of code is not that much, and we saw that composable architecture before. You can just as well build that one in GCP. I mean, we're not talking years to build that solution. We're not talking months, we're talking weeks. And anyway, you might be developing with Python today, and in 10 years, when the system is obsolete, Python is not the thing anymore. something else. Might be Java again, I don't know. It will never be Java again, no, I'm just having a little bit fun here. And the multi-cloud strategy, yes, it makes sense in a few cases. You really, really need to consider it. It is not a decision you or anybody in this room can make. It's something you need to bring upwards and saying, are you afraid of Microsoft screwing you over, or afraid of Microsoft going bust, or what will happen if that system is down for 2 days because, I don't know, Azure storage went down or something like that. It has to be in all the data centers, of course. It's a conscious decision you need to make. On paper, it makes a lot of sense, and it's super common IT practice, but once you get into it, it's fun, but it's a lot of work, and it's seldom used. Any questions? There's one more here.
Your boss talked a lot about agentic work.
Yes.
How do you think it will affect now?
So,
Think about you map software into, think a little into traditional software terms, but maybe change.
So really fast. My boss, I guess you refer to Satya. I've never met him, but he is my boss. Yeah, and he refers to everything is going to be agentic. Yes, I think so too. Meaning you're going to see, there's going to be more software written, so I'm not worried as a software engineer. I would probably, if I don't have data science skills, I'll need to move over there. But there's going to be more and more software written, but you'll also see a larger chunk being able to be developed with low code or no code software by my sister, for instance. And that has grown rapidly. Like most systems can actually be built, but if you have a performance requirements, some constraints or anything like that, then you'll need real engineers like us to build those systems. So we just move higher up in the stack. But if you're not utilizing AI to sort of get there, and I'm not a super AI advocate, then you're losing out. Right? Because for instance, I used to be a Java developer. I'm switched to C#. Nothing to do with I jumped over to Microsoft because I never haven't written much code in C# while at Microsoft, Python, Rust, whatever. But when I'm at a customer working and they might use an obscure language, I can still be productive. So, yeah, I see AI everywhere. AI in the services, we need to rely on it. Again, SRE agent, you end up having an automated system that automatically does a lot of things for you because it can act fast without you being on call. And sometimes it will go wrong, sure. And then you'll blame Microsoft or whoever built the system. But that's also fair. Other questions? Yeah.
In terms of multi-cloud strategy you were talking about, so I'll ask more like specific cloud question. In terms of Oracle integration cloud, what do you see the biggest value and opportunities that Azure AI services could bring into this?
So the question was about Oracle integration cloud, and I know nothing about it. So I can't really respond to, sorry. I've never used it, know nothing about it. All right, thank you very much.